Hey boys and girls, welcome to 6th grade life science, and today's standard that we're going to cover states develop and use food chains, webs, and pyramids to analyze how energy is transferred through an ecosystem from producers to consumers. Then finally end with our decomposers. Welcome to my virtual classroom. Let's talk about the three words that were wrapped into that standard. The three main words: producers, also known as autotrophs because they are self-feeders. Producers make their own food, so they don't have to be fed. They get their energy from the sunlight, and then they go through the process of photosynthesis, and within that process, they make all of the chemical energy needed for that plant life to survive. Then we have our consumers. Consumers are species that eat other species for survival. This includes herbivores, carnivores, and omnivores. So let's go over those again real quick. An herbivore is a species or an animal that eats only plant life. A carnivore is an animal that eats only meat. And then we have omnivores, and omnivores eat both plant life and meat. And then last but not least, we have our decomposers. And decomposers are smaller organisms. Some are microscopic, some we can see with our eyes, and they include bacterium, fungus, invertebrates that feed on and break down dead plants like various beetles and worms and lots of insects and critters. And they break down the dying and decaying, or the dead and decaying matter, and they turn it back into organic nutrients that are available in the ecosystem through the soil. So everybody has its role. Now let's figure out how those roles all get divided up into our energy pyramid. So the energy pyramid is a graphical representation. It is an image, which I'll show you next, and it's a pyramid. It's a three-dimensional shape, and it starts at the bottom with a broad base, and then it works its way up to a more narrow point because that's where we have the smaller number of organisms. And it shows how the energy at the bottom starts high, but as you work up, the amount of energy available decreases, and so does that size of that pyramid. It also decreases, as well as the number of species within each level of that pyramid also decreases. So it's a visual image of the size and scope of all the various species within an ecosystem. Within that, we have our food chains and we have our food webs. And a chain is a part of a food web. So we'll get to that as well, and you'll see how that all works together. So here is our graphical representation of our food, or the energy pyramid. At the bottom, we have it's a teeny tiny little area, but it's broad and vast, and that is our decomposers. Now the biggest area is level 1, and most often on these graphical representations, the decomposers can be even lumped up at the very top, but in this particular one, it's at the bottom. The biggest and broadest area we have on our food energy pyramid is all of our producers. And those are, again, all of our plants. There are autotrophs. They don't have to eat. They create their own energy through the use of the sun by way of photosynthesis. The next level we have, and if you notice, the producers have off to the left side 100,000. So that 100,000 represents kilocalories, and we're going to use a simple whole number like 10, 100,000, 10,000, 100,000, because mathematically you can see the change through the various trophic levels of our food energy pyramid. So after the producers, the next level we have are our primary consumers. Primary consumers are herbivores only, which means they only eat plant life to survive. And you're going to notice the amount of energy available to those producers is now smaller. It decreases by 10%. And so you can look and see that decrease that has taken place to the left side. We went from our producers to our primary consumers, and that number has gotten smaller. The size of the pyramid that section is on is also smaller because there are not as many primary consumers as there are producers. So again, a visual image of how the species in that area take in or have less energy available to them, and there are fewer of those species. The next levels are secondary consumers. Secondary consumers are carnivores. They eat the primary consumers. Some of them could be omnivores that could eat both plant life and other animals. And again, that area is smaller. So you'll notice how it's further up the pyramid and how that part of the pyramid is more narrow. Then we have our tertiary consumers. That's some of our higher level predators. Those guys are meat eaters only. They're not going to go and graze down onto the producers. So our secondary consumers can be carnivores or omnivores. Our tertiary consumers are carnivores. And then last but not least, we have our apex predators. And that's the smallest species population we have. And apex predators are the top predators of that ecosystem. So depending on what ecosystem you're in, for example, an ocean ecosystem, orca or a killer whale, those are apex predators. In a Yellowstone National Park ecosystem, our brown bears, our grizzly bears, those are our apex predators. Our mountain lions, those are our apex predators. And if you think about it, there's not as many of those within the population. So you can see how the pyramid represents not only the decrease of energy available, but how small the size and number of species are in each one of them. All right, so let's talk about what a food chain is. So a food chain is a series of a larger food web, and in a food chain, it shows you how one organism survives from another one. And the arrow indicates the direction that energy is flowing. So when you look at like the poster on the left side, it starts with the sun to the producer, and then the producer to the primary consumer. It's like plants to what appears to be a rabbit, and then the snake. And then after the snake dies or leaves behind remains of the rabbit, then the decomposers come in and break those things back down and put them back into the earth. On the graphical image with the circular motion, okay, you can see the same thing. It starts with the grass, the producers, and that arrow moves to the grasshopper because that's where the energy goes. And then the grasshopper goes to the mice because the mice are going to eat the grasshoppers. And then the snake, the arrow is pointed to the snake because the snake is going to consume the calories. So the arrow flows the direction the energy is going, the direction the calories are going, and the snake eats the mice. And then finally we have the hawk, and the hawk is going to scoop up that snake and consume that snake. And then anything that's not consumed, or eventually when the hawk dies, the decomposers then take on their role and they break down all of the decaying matter and return them back to the earth. So the next thing is a food web. So a food web is a much bigger picture. So on the food chain, you just saw one sequence. On a food web, you see a much larger sequence. And you can see lots of different interconnections and interactions between organisms. So it states that a food web is the natural interconnection of food chains and a graphical representation. Usually it's an image. Sometimes you'll just see them with like the words. I always like the ones with the images. And it shows you what eats what within a particular ecological community. So on this particular graphic, you can see that we have water plants, we have dry land, and we have dry land plants. And then you can see all of the herbivores on that bottom row, and those arrows are moving up into that food web, and they go on up through the various consumers until you get to those top apex predators. And then this particular food web doesn't include the decomposers, but all of these guys are going to leave behind decaying matter, and the decomposers are going to come in and they're going to break down the rest of that matter and return it back to the earth. All right, so if you guys have any questions, let me know. Thank you.